Hi guys, Buildzoid here, and today's not a great day. This doesn't work, and dare I say it's not my fault that this doesn't work. But yeah, so anyway, the story here is, so this right here is a Vega Frontier edition that was sent in by the same guy who also sent in the Titan X Maxwell. He also sent in one other Vega card, and I think I actually have that working. This card, the reason he sent it to me is it had liquid damage on it, and well, it doesn't work, and like it still doesn't work. And at this point, it's just like yeah, well, okay, so let's just fire it up. So right now I have the V-Core VRM turned off. So this is a Galax Hall of Fame power board. That's a really nice 16 phase power board. Like I love these. If all like these are great. The voltage range on it is a bit limited. It only goes up to 1.6 volts, but it is a really cool power board. Anyway, if we fire this up right now, it actually fires up. But that's because there's a GT 1030 back here. And so, as you can clearly see, on the capture card, we do actually have an image, which, yay, okay, that's great. Yeah, it just takes us to the BIOS, which is what you'd expect. Now, if I enable this, because the power card has a really convenient feature where we can turn it on and off, if I enable it, this will not work, which really sucks. But anyway, I'm holding my finger here because hopefully you'll be able to see the LED light. Oh wait, the LED's over here. So you can see the LED lit up. And yeah, that's just an LED to indicate that the GPU is running. That is getting really hot, so we're just gonna turn it off again. Wait, did it actually manage to turn on? Because it's supposed to just hang. Um, we can try fire it up again. So, okay, 97, and we get a whole lot of nothing. And we're not going to get anything because, yeah, as far as I can tell, this thing is dead. So, hell of a process, actually, getting to this point. This is temporary. This is not fully attached, so this is not going to be that difficult to take off. But, yeah, that's really disappointing. Like, at this point, my conclusion is that the thing is brain dead because we have that voltage regulator works, that works, that works. V-Core works mostly because I bought, like, well, so the original issue, um, so the card had water damage, and the guy who sent it in said in his email that basically the repair store that he took the card to had a shorted power plane, which is wrong. There was no short on the power plane. This is a Vega. I assume what the store did was they tried to measure the resistance of the GPU core, and they had no idea that a healthy Vega, has like a 0.15 ohm GPU core resistance. So this thing looks like a dead short circuit even if it works. The only thing, like the only GPUs that are even worse for troubleshooting than Vega cards are like high-end low nanometer NVIDIA GPUs, because those, like a 1080 Ti is I think 0.08 ohms, where it's this thing, like, it looks like a hell of a short circuit, but that's fine. That's what a 1080 Ti is supposed to look like. Same goes for like a 2080 Ti. If you check V-Core to ground on a working 2080 Ti, it's less than 100 less than 100 milliohms. So these are very low resistance GPU cores, not shorted. Um, but it does look like it's short. Like, it would look like it's a short circuit, but it isn't. It's fine. What was the problem with the card was there was a shorted out driver IC. So I fixed that by just replacing the entire well, initially I just pulled the driver because I was like, this card uses a international rectifier IR35217 voltage controller. Man, these power connectors are so hard to remove without two hands because I'm holding the mic in one hand. I decided, like, I should have just used the lav mic. I don't know why I decided to do the things this way. The thing is, I didn't want to bother with like switching the mic inputs and changing the levels, and this was supposed to be a quick video. Damn it, let go, you stupid connector. The thing is that e-power isn't soldered on that well, so I'm actually kind of worried about it, like, breaking off. Well, actually, at this point, that doesn't really make much of a difference. The card's dead anyway. It's not like I can really use it for spare parts either. I mean, I guess I can pull off the MOSFETs, but... well, actually, yeah, but I could pull off the MOSFETs even if the E-Power, like, shredded the power plane, so it's not really that big a deal. Anyway, yeah, there we go. So, actually, let's power this off where I'm going to accidentally turn it on while trying to pull the card or something stupid like that. Okay, there we go. Come out. Oh, right, this thing's covered in flux. I don't want to touch it there. There we go. So, where was I going with this? Right. I'm going to have to switch hands. Anyway, so there is... Do I have it the right way around? I do have it right way around. Okay, come on, camera, focus. So, there you can see a bunch of soldering around that... there, driver IC, right? Like, big fat wire, and then, like... Man, this is so awkward for me to angle. That chip. Right. Well, okay, if you know what a driver IC looks like, then you can see that I've replaced that one, and all of the supporting circuitry around it, because that was actually shorted out. Like, this... Oh, great, the autofocus is screwed up again. This video is gonna suck. This is what I get for trying to... Because the thing is, I've given up on this card at this point, so I'm mostly like, yeah, I've given up on this. So, I've also given up on the video. I'm not in a great mood. Like, the thing is like, I'm mostly just kind of like... Like, I just want to get over the cards. So, driver chip over here, no worky. I replaced driver chip. New driver chip worky. New phases worky. Actually, if we flip the card over, I did a really good job of that. This is the first time I've ever actually replaced direct FETs. And honestly, like, yeah, you can kind of tell that they're not quite right. But 3 of the phases right there have had their MOSFETs replaced. And, like, one of them, well, more like 2 of them, you can really tell that the MOSFETs aren't that straight, but I replaced 3, so I did a pretty good job. Funnily enough, the straightest of the phases is the first phase I did. For whatever reason, like, basically, as I kept working on the, like, as I worked along onto the other phases, for some reason... I guess I started thinking about it too much. That's generally my problem with doing anything, is, like I try to micro optimize things past the point where it makes sense to, and then they end up worse than I started with. So yeah, anyway, so replaced the MOSFETs, got all the phases run, like replaced 3 MOSFETs, because the thing is, one of the phases straight up exploded. Like, the phase with the driver took out 2 phases, and so I desoldered the MOSFETs just in case. I didn't really want to leave potentially damaged MOSFETs just kind of hanging out on the card, because, I don't know, maybe... Like, there wasn't any short circuit to the actual power plane. Power plane to, like, V-core to ground was fine, V-core to 12 volts was fine. There wasn't any major short circuits, but I wasn't really, like, comfortable leaving on a bunch of MOSFETs which just had their driver die in some way. Anyway, so I pulled the MOSFETs for 2 phases, like, these 2 phases right here. And then this phase over here blew its high side, so I had to replace that MOSFET as well. Like, the high side MOSFET just exploded, so that was really surprising, because there was nothing wrong with the driver for that one. But yeah, I ended up replacing that that phase as well, and as well as the low side for that phase. Like, I just replaced all of the MOSFETs there. So the cool thing is, I actually got some, like, for the first time ever, I've replaced direct FETs. I've never tried to do that before. And I was successful. I actually had all 3 of those phases up and running. But before I rebuilt the phases, the issue I was running into with the card is because, like, international rectifier controllers, if you pull a driver, the controller should be able to figure out that, hey, wait a minute, there's a missing phase, and it should be able to work around that. Like, within their feature set, they have the capability to just kind of keep working with missing phases. They're designed to be able to do that. But the thing is, this card, right as the GPU core is supposed to initialize, instead of, initializing, it would shut down the vCore VRM, which is really weird, because the way it was shutting down the vCore was like, I still had memory power. I had every other rail on the card was still running, but vCore was gone for some reason. And the thing is, there was no liquid damage anywhere around the actual voltage controller itself. The enable line was somehow getting pulled low. Talking to the controller using the USB 005 was not possible because for whatever reason, when the GPU core fired up, when the vCore shut down, even though vmem was running and the controller handles both vCore and vmem, the controller, the software for the controller would say that the controller isn't running, which that makes sense considering that the enable line was low. But in that case, why was the memory power still up? I have no idea. So that got really, really annoying. And initially I thought, okay, so it's shutting down, like the vCore is shutting down when the GPU tries to initialize, because as part of the initialization process, because the card actually boots on like 4 phases or something. Like it doesn't fire up the entire VRM. You only have like 4 phases running during the initial, initial startup. And then after that, it actually fires all of the phases, which, I use the oscilloscope for. And that's also how I know that the 3 phases that I replaced work. Well, actually, one of them is one of the startup phases. But then the other 2 were actually phases that only fired up during the initialization process. And so I'd get like several hundred microseconds of every single phase on this card running correctly, and then just turning off for no reason whatsoever. And yeah, I couldn't find any faults like that. Like the controller, it wasn't over temperature, it wasn't over current, it wasn't a phase fault, it wasn't like there's a lot of things that it wasn't. And so at some point I was just like, okay, screw this. I'm not dealing with the controller. I'm just going to bypass the entire vCore VRM. Now, the problem with bypassing a vCore VRM on a VEGA is that the vCore VRM is controlled by the same controller that does your memory. So if you do something evil to the vCore VRM, like I've done here, you screw over, like the controller gets very upset about that and turns off the memory VRM. So that is sorted by this smaller power board on the back, the thing down here. So this is a Elmore Labs Ample, which basically it's just a tiny little single phase VRM, and it's designed to handle, I think, up to about 20 amps. And it was really cool. It has a ridiculous voltage range. It can go from like really low voltages all the way up to like, I think it goes from 0.9 to like 3.3 volts or something. It has a potentiometer for setting the voltage, adjustable switching frequency, comes with a cute little heatsink. Yeah, perfect for powering memory rails, memory controller rails, various random annoying supporting rails that shut down when you screw up the vCore VRM. So put an ample on the memory power, sorted that out. So we got memory power, we got vCore, we got all the supporting rails like 0.8 volts, 0.9 volts, 1.8 volts, all that stuff was running, except this rail down here, which this rail down here with the wires going to it, that's 2.5 volts down there. Yeah, 2.5 volts decided that it was going to sit at 0.6 volts, which I actually think what was going on was it was in some kind of like reset loop where it wasn't fully turning on. So it was like on the multimeter, it looked like 0.65, but I couldn't be bothered to check with the oscilloscope. So ultimately I just decided screw that LDO. Because the thing is, normally the way you'd fix something like that, the way I deal with something like that, it's not really fixing it, it's actually breaking it further. But the way I normally deal with controllers that don't want to fire up is I find the transistor controlling their enable line and remove the transistor, because if you remove the transistor, then it has to fire up. The issue is I couldn't find the transistor, which is a similar issue to what I ran into with vCore. There's no enable transistor. How is the enable line getting pulled low? Like, what is pulling the enable line low? I can't find the the thing that's doing that, and I don't have schematics ever. So yeah, that wasn't going anywhere. So ultimately I decided I'm not dealing with the stupid LDO or its enable line, and I bypassed it with another ample, which you can see right on the front there. And that one's just set to 2.5 volts output, which I love amples. Like, the amples are great. Like, working on this card, the amples are freaking awesome, because they are just so convenient for exactly this kind of thing where it's just like there's a stupid minor rail that doesn't want to turn on. I wonder what I'm going to do. Ample. You have memory power problems, ample. Memory controller, ample. 1.8 volts, ample. Like, honestly, if every single VRM on this stupid thing shut down, it would be 1 e-power and like 5 amples in total, which just so happens to be how many I actually have. So I still have 3 more that I can use for other projects, though I'll be pulling these off, of course. Yeah, they're not staying on here. This thing doesn't work. So at this point, I replaced all the replaced all the phases, eventually replaced VCore, complete like bypassed VCore, bypassed memory power, bypassed 2.5 volts, did basically everything in my power to just force the GPU core to turn the hell on. And well, the state it's in now is that it doesn't let the motherboard initialize. So I have to conclude that at this point the core is like, not only did the water damage take out a driver and like a phase, but maybe the phase exploding took out the core on the way. That's not really that impossible because it was a high side explode. Like the thing that died was a high side MOSFET, and dying high side MOSFETs have one major flaw where they tend to short circuit the 12 volts to the output. What do you think happens when? And the thing is, like, your power supply's over current protection or short circuit. Well, I think for that it's OCP that trips. I don't think it's short circuit protection, but either way, your power supply is going to trip when that happens, assuming your power supply doesn't suck. If your power supply does suck, then you're probably going to end up with a fire because you're just sending 12 volts into something that's a 0.1 ohm resistor, which that's going to give you a very large amount. Like, this is like 120 amps or something. So, yeah, 12 divided by 0.12, you're getting, well, 0.1, you're getting like 120 amps. And the thing is, GPU core resistance actually drops when the cores are running. So, yeah, anyway, if you have a bad power supply, a high side MOSFET shorting can be can be like that. That's how you see the videos with people where they have like GPUs where it sends out smoke and like flames and stuff. And it's like, if you're getting flames, your overcurrent protection is probably pretty crap. Like, just saying, because the whole point of the OCP is that it trips before that much energy gets dumped into some circuit somewhere or some short circuit somewhere. But anyway, so for me, I got a puff of smoke and it turned off, which is what you'd expect. I didn't get the whole fire thing, which some people somehow managed to get. If your power supply manages to set something, like if a failing component manages to catch on fire because your power supply is so slow to respond, you should probably consider getting a better power supply. Like, honestly, the funny thing is, normally I don't test sketchy things like this on my EVGA 1600 watt power supply because it's a 1600 watt with a single rail. So like, the OCP on this thing is sky high, even when like it's supposed to trip. Like, normally I'd be using a multi-rail, but anyway, I was kind of lazy with this whole thing. The thing is, ultimately, yeah, I guess when the high side MOSFET blew up, it took the core out because at this point, like, the thing is, it just won't initialize. Like, maybe there's a corrupted BIOS on there or something, but corrupted BIOS, I'd be like, okay, so it should still like turn on, and then we could go into Windows and like flash the BIOS, or like I wouldn't expect that to stop the entire motherboard from turning on, but this thing, like, it just stops the board from initializing. Like, it just won't turn on. Which, yeah, I just have no idea what to do about that. So, I'm guessing the core's gone. There's really, like, the annoying thing with dead cores is that there's nothing you can do to test for it. It's just like, well, like, I have all my voltages, check. There's no display output. Core's probably gone. The HBM, like, something, like, basically there's no issues on the PCB itself anymore. There's issues over here. Because like, all the PCIe capacitors are in place, and even if some were missing, all that should happen is we should drop down a link speed, and like, that's not an issue. We have all the caps. There's no obvious PCB damage left. The only damage the only area that had actual like water damage signs, which like the corrosion was this top area up here. So like, I wouldn't reach the PCIe slot anyway. So I don't know why, like, at this point, it's just like, yeah, the core is doing something stupid. And so the core is probably dead, is my conclusion. Like, I don't know what else it could be, because it just doesn't want to start. And it has all the voltages. It has, like, everything is present, doesn't turn on. But I did blow a high side. And a high side exploding is a pretty good sign that, like, there's a pretty good chance that that took the core out. So, yeah, I'm pretty well, like, I'm sad that I didn't fix the card, but I'm not really that sad about the card itself because it was fan mail. The guy sent it in because he didn't really expect me to get anywhere with that. Like, the repair shop that he took it to already told him, like, they're not able to repair it, which they were wrong about the diagnosis. There was nothing wrong with the V-Core power plane. There was an exploded drive, like, there was a shorted driver, and there was a MOSFET that blew up. Like, that MOSFET was fine until I tried to turn the damn thing on. So yeah, that thing. So the exploding MOSFET, that's bad. The core being dead, that's the worst part, because that's literally, like, at this point, the only thing you could really try to do to fix this is to get, like, a working Frontier edition and take the core off of that and put it onto this, which is, like, that's stupid. Why would you do that? Right? Why, like, that's just dumb. So yeah. So I don't really consider the card, like, I'm not annoyed about the card dying. I'm annoyed with the fact that I went through so much freaking, like, I did so much work. And, like, probably the most difficult soldering I've ever bothered to do ever. Like, that driver has, like, jumper wires directly from the pins to various things, because there was, like, a bunch of test pads that the water just completely corroded into oblivion. Like, they weren't there anymore. So I had to bridge, like, the driver to, like, the gates of the MOSFETs and stuff. And I was like, that's some very fiddly soldering work, because you're going directly to the pins, which is fine. Like, well, it's not like, I think I've gotten a little better at that. I also figured out how to replace well, I don't really figure, like, I finally got an opportunity to replace direct FETs on a non-working card where I actually got to prove that the swap worked. So I'm pretty happy about that, where it's like, okay, I know how to replace direct FETs. Now I just need to do it like, a bunch more times before I'm willing to do it on a, because the thing is, I have a bunch of cards that have direct FETs, but they have, like, weaker low sides than what you can source on a lot of dead AMD GPUs. And so what I've been thinking about is, like, I could upgrade the low side MOSFETs of, like, I have a GTX 680 where I could swap out all the low sides, which would be, in my opinion, pretty cool. So that's one of those things that I want to do. And obviously, like, yeah, this card got me an opportunity to practice some of that. I can also use it for spare parts. There's a bunch of perfectly good polymer capacitors on the back, as well as a ton. Like, there's actually a lot of really nice high voltage multi-layer ceramics on these. So, like, well, high voltage 16 volt capacitors, but still. So yeah, there's a lot of, like, spare parts potential in the card at this point. But the thing I'm annoyed about is I spent so many freaking hours chasing random issues. Like, first it was like, okay, first we fire it up without the phases. Okay, it doesn't work. Okay, let's rebuild the phases and rebuild the driver and, like, put a whole bunch of time into getting the VRM into perfect working condition, and this thing still doesn't want to bloody power on. And then it's like, okay, so if the VRM's being stupid for no reason, let's just bypass the VRM. I bypassed the VR. Like, the crazy thing is, if I had given up on the card at the point where I had the VRM up and working, I could have literally, like, took the core off and used this as an e-power. Like, I could have used this card as a power board because the VRM was in like, perfect working condition. All 12 phases were firing up. Every single one of them was running. Every single one of them was running correctly, at least according to the oscilloscope. And instead, I was like, no, I'm going to get the stupid freaking core to work. And so I go out of my, like, I pull all the inductors, I pull the controller, I freaking solder the e-powers on and the amples, and it's just like, and that's, get to this point, and then it's like, the card now actually, like, initializes, well, tries to initialize the core and fails. And it's just like, you have got to be kidding me. right? Like, this is the thing that, like, I'm always really like with any card where it's like, oh, the VRM failed for some reason. There's a pretty good chance that the everything after the VRM is also gone, right? Which in the case of a V core on something like this, yeah, the core is gone, right? Like V core takes out if V core breaks and you get 2 volts on your V core output, like bye bye core. It was nice knowing you. But you know how you became a clever piece of sand? Well, now you're going back to a stupid piece of sand. Say hi to 3 volts for me, or 2 volts. Like, even 2 volts is going to very rapidly destroy a GPU. Um, so, yeah. So, I'm just mostly disappointed that I spent like a day on this thing, only to find out that, like, the core's. Like, I'm still not 100% certain that the core is gone, but I'm like 99.9% certain that the core is gone. Because like, it's brain dead as far as I can tell. Like, the motherboard can't start with the card installed, which is like if the motherboard didn't see the card, then I'd be like, okay, the core is very dead. But the motherboard doesn't. It's not even like it doesn't see it. It's just like like why? Like, I've never run into that. So yeah, I'm really not sure what's wrong with this card at this like I still think the core is just gone. Um, There's also a chance that me constantly like reheating the PCB to like pull drivers, pull MOSFETs, pull inductors, put drivers back on, put MOSFETs back on. Like, there's a chance that also, like, I cooked the core by doing that, because like all of that work is right next to the core, right? Like, we are talking about this area up here, and the core is right below that. So I might have roasted the core doing that, but yeah, there's just no way for me to diagnose the card, because like, I can't even get it to freaking start. So it's just like I just like, yeah, and I'm annoyed about that. Like, I'm really really annoyed about that, because it's so unsatisfying. Where it's like, yeah, core's like, I don't even know if it's for sure dead. It's just it doesn't want to start, and I can't think of anything else that it would be at this point, because we have all the voltages, we have every single voltage. And I don't, like, again, I don't have schematics, so it's not like I could go consult if there's some like enable or safety feature that's being triggered that's making the like. But even then, it's like, why would it not let the motherboard start? So yeah, I'm like, I'm annoyed. I'm really really annoyed with it. Um. So yeah, at least the Titan was a success, which you're gonna see that in a later video, because I'm not finished with working on the Titan, and yeah, like, right now the Titan just kind of works, but I want to get it like in a really good condition before it shows up on video. But this thing is just doesn't work. Like, everything on the card worked. Everything worked except the freaking core. And like, the last crazy possibility that I'm considering is like, maybe both of the BIOS chips somehow got corrupted. But I find that extremely unlikely, because even then, I would expect it to still start. Just the motherboard wouldn't pick the card up, or like the mother, yeah, like, yeah. So so yeah, that's it. So this is another fail. I'm really like, every single dead Vega that I've tried to repair so far has not, like, well, there's that other Vega that I got sent, but that one basically just started working when I mounted a heatsink to it differently. So I think that one just has like BGA issues, which is like, well, that's not really like something that, again, that doesn't really count as a repair. That's just kind of like reflow it and hope for the best. Um, which I do intend to do, but like, I don't have high expectations for that card having a long lifespan after that. Whereas this thing is just like, well, this doesn't bloody work, even though like I did everything correct. Like, that VRM literally ran until we get to the part of the post process where the GPU core is supposed to start up. At which point, for some reason, the GPU core, I guess, told the VRM to shut down, which is just like, why? What could possibly cause that? Oh man. So yeah, that's really no fun. Anyway, like ultimately, I'm kind of happy that I get to use the Hall of Fame for something else though, 'cause like the power board here, there's like a totally different project that I had planned for it, and ultimately I put it onto this card because I was kind of considering just stealing a VRM. Like I have a bunch of like in progress power boards, and I was kind of considering using one of those, but then I ultimately decided, you know what, like I just want a quick test of if this stupid thing even like has any chance of turning on. And so I pulled out the Hall of Fame power board because this is super convenient to work with compared to some of the other options. And yeah, it doesn't work. So that's it for this video. Man, this thing's 30 minutes long again. Like honestly, like about 5 minutes ago, I was already considering ending the video. But because at the end of the day, like I'm at this point, I'm not presenting any new information. It's just kind of like, yep, I'm very annoyed because I put way too much time into fixing a GPU that wasn't really repairable in the first, like probably wasn't repairable in the first place, or more like probably wasn't repairable after the moment when I turned it on and the like one of the high side MOSFETs exploded. Which I still don't get like why that MOSFET exploded. Like, that's also kind of well, I don't know. Maybe I cooked it. Like, there's a chance I cooked the MOSFET pulling the others, or something like. Yeah, no, that is possible. I might have cooked it, or maybe there was some like I don't know. Maybe the card like the thing is I never fired up the card in its initial condition, because a lot of the time if you have something where it's like if you have say a dead high side MOSFET, every time you power cycle the GPU, you are causing more damage. So the probability that you'll be able to fix it after every power cycle gets lower. So because of that, I have a policy of not turning on stuff until I know that there's no obvious short circuits. Because if there's a short circuit from V core to 12 volts, every time it power cycles, things get worse. Please don't power cycle things with short circuits. Because you're just dumping more energy into something that's already like, well, yeah, you're just dumping more energy into a short circuit, and that just makes things worse. um, every time you do that, it just you know like causes more damage. So yeah, anyway, I'll end this video here. I guess I still have like a whole set of phases over here that I can steal MOSFETs off of. So yeah, I guess thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Thank you to the guy who sent over the cards. Like, I mean, I did learn how to, I got better at soldering here, or more like just got brave enough to try certain things as far as soldering goes. It's a better way to put it, because like the thing is, I didn't really like learn a new technique or anything. I just kind of told myself, let's do this, and then I did it, and it was like, damn, it works. I don't know, like, is it supposed to be that easy? I'm not really sure, but yeah. So yeah, so thanks to the guy who sent the card over, and right, if you'd like to support what I do here with the channel, I have a Patreon. There's a link to that down in the description below. And then there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, same purpose as the Patreon, except unlike with the Patreon, you actually get merch in return instead of kind of nothing if you use the Patreon. So yeah, there's links to both of those down in the description, and that's it for the video. So thank you for watching, and goodbye.